Welcome to the Japan Unix booth here at INTERNEPCON Japan. I am joined here today by
Shinichiro.
Shin, that's it. You said to me earlier, Shin Kawakami.
Yeah.
Okay, and you are the basically the supervisor of this new laser product that we're going to talk about today.
Yeah, sure.
Okay, so maybe you can tell us a little bit about it, because Japan Unix, as we know, has been in the laser soldering business for a long time, but it's always been a very direct process. You've got a new system here that controls the profile better. Maybe you can tell us a little bit about it.
Okay, so the main point is the number of the control points. Actually, there are some similar kinds of control system for the competitors, but it's just a control and for the temperature only.
Right.
And this means the customer cannot have the fixed laser profile.
Right.
For example, for the mass production, the customer might ask for the certain, like a PCB or some products, what is the laser fixed profile?
Right.
But in this case, the customer cannot have the fixed laser profile because just laser power is following to achieve the target temperatures. But for our system, they can control for both the laser power and the temperature.
Okay, so you're saying the laser profile changes as the board gets warmer with the heating process, yeah?
So the basic concept is still same as from the origin, and our start point for the laser system.
Okay.
So we believe the stable laser power enables to have stable heat transfer.
Right.
But sometimes, because of some PCB status or some external environment, some heat temperature might be changed because of the reason. So in this case, the control system is working to achieve the target temperatures.
Right. So how many points does it measure over?
It depends on the products. So we can set the number of the point to set the temperatures.
Okay.
We can arrange, it depends on the product.
Right.
Yeah.
And so, is this something though that can be used easily in the field by an operator, or do they have to have a lot of process knowledge to be able to use it?
Yeah. Even for using this kind of controllers, we believe that some feasibility study to find the best laser condition is still necessary. So for that stage, our engineer needed to find the best laser profile, because the temperature is just measured by the pyrometers, but we might have to think about some case to broken the pyrometers. Even broken the pyrometer, if we have the best laser condition, we can still continue to produce.
Right.
But that is the main point.
Right. Okay. Because you're using pyrometers basically to measure the heat source.
Yeah. So for the other similar kind of system, once broken the pyrometer, there's no fixed profile, so no continue to the production.
Okay.
Yeah.
Great. Well, Shin, thank you very much for giving us a quick look at this. We've got another. Some more robotic systems at the other end of the booth that we want to take a look at. So
yes, the new desktop robot is enabled for the IoT or Industry 4.0.
Right.
Yeah. So we are always available to output any information like a robot status. Yeah.
Okay. So we'll go over there and take a look at these just now. Okay.
Okay. Thank you.
So here we are at a different part of the Japan Unix booth, and I'm joined by Hitoshi Ojami, and we are going to look at the DF monitoring, is it? Which is a software system that basically produces a lot of video information on the process, and also has a data trail on the manufacturing process. So maybe you can tell us a little bit more about how it works.
Okay. Actually, we established the new design of the machine, and at the same time, we actually we call the DF monitoring, and this DF monitoring can get the information from the machine, and main point is you can see the temperature and also if you're using the CCD camera, and you can check the soldering. So during the soldering.
Right. So basically, the system measures the temperature, and if you see a spike or you see something that doesn't look right, you can then mine in and look at the video for that part.
No, like an inspection system, but just only for the monitoring, checking. Right. So I want to say is if normally we recording both of the data, which is video and thermal behavior, and once if they have some issue about the soldering result, you can just stop the recording or whatever, and you can just return back to the synchronized position which have some issue. Right. So now the video also synchronizing with the thermocouple sensor. So once you return back, automatically video is going to back to the position which have some issue. So the customer can easy to find what is the reason of the issue coming up. So easy to fix and easy to adjustable. Right. So now if without anything, customer doesn't know about what was the issue. Just only show only see the PCB and the result, and this one is not good, but we are not sure. Still need the monitoring. Right. To find out what is the reason. But using this system, then just easy, just back and all this. Some maybe affecting the position or some like a soldering condition. So both in the customer side and also for us, it's very easy to handle.
Right. It's obviously a very good system for traceability and looking historically at what has happened. As you develop the product, are you planning to sort of maybe look at certain scenarios that are typically that happen with defects or potential defects, and give some more instructions to the user on what it might be? Would that be something that you might like to do in future development, or where do you see this going in the future?
Actually, this system is you can just set the PC into whatever you want, and you can connect in the maximum like 4 robots, and control only the one PC. And using the one PC and control the 4 robots, and this one is moving, it's moving, but this one happening. So in that case, the engineer, the manager call to the engineer, and then immediately fix. So.
Right. Okay. So it can do up to like 4 systems at once.
Yeah, maximum 4 right now. Yes.
Now you've got some other automation further down the booth here, which is showing different forms of access. You've got one where the boards can be twisted in both directions. Yeah. Why are you doing this? Just to give you extra maneuverability so that all the movement's not built into the head?
Yes, it depends on the product, and the customer have some like they want a solder like here and also solder one here. Then this is actually the optional facility, and if you can put the additional motor on the robot, then we can adjust in the after finish here, they rotate, and then we can do another soldering. Right. So you don't have to use dividing the 2 robots.
Right. Okay.
So.
Good. Interesting. And you've also got another one which is like a turntable as well. So it can go in a turntable and it can move on the X and Y position, and then so therefore the head can do all the oblique angles and tilts. Yeah.
Yes. Normally the machine is a 4-axis, X and Y and Z and theta. But using the 2 more additional motor, then it can be like a 6-axis. Right. So more like a flexibility.
Right, that's very flexible, 6 axes of movement. Yeah. Okay. Well, I want to thank you sincerely for all your help today and showing us the new products. Very exciting. Thank you.
Thank you very much.